Enrico Bertino is the co-founder of Italian GenAI startup called Indigo AI. They closed, I think in January, right, a very good B round of 10 million euros, and it's going to talk about how to actually put language model into production. So thanks a lot.
Thank you. What? Cosa? Devo salire? Ah. Scusate. Hello, everyone. I'm Enrico. I co-founded Indigo.ai 10 years ago. And so we started to build virtual assistants and chatbots in 2015-16. And it was another, let's say, era in AI and what was called natural language processing and machine learning. And so today I want to give you my personal point of view of what happened in this field and some, let's say, controversial point of view about what's happening right now with generative AI and chatbots. In Indigo, we have a platform to help companies understand their customer needs better, so talk with the customers. And for the technical point of view is like creating automation in the conversations between companies and users. And we started from in a moment where it was even very difficult, very hard to understand only the meaning of a sentence, a meaning of a user question. And I want to start from that prehistoric times in 10 years ago when almost every chatbot was like, okay, I don't understand, and the user was like, I want to speak, I want to talk with a human. And there was no understanding between machine and humans. And the reason was that the pipeline behind the chatbot, the virtual assistant, was very simple. Classification of an intent of the user, extract some entities like product names, so on, retrieve some knowledge, and answer with a static templating answer. And everything in entities, knowledge, and answering was without AI. The only focus in that moment was about understanding the intent. And there was a word about text classification and intent classification. And also inside the research team inside Indigo, we were focusing only in this task, also in other stuff, but this was the main task to work on. And the intent classification was quite easy, starting from a text, vectorize the text, classify the vector, and like reach a label that for us was an intent. There were a lot of challenges because there were a lot of classes to classify with few observations in the classing for the classes, so it was a lot of challenges to handle. And the baseline at the time was this. For us, it was a little pre-processing, so cleaning the text, correct some errors, and extract entities with regular expressions. Use TF-IDF, it was the very naive approach to have a sparse representation of a text, so no synonyms, no meaning of the words, only a sparse representation, and subtor vector machine for the classification. Super easy baseline. With this baseline, we reached higher performances than Google Dialogflow, IBM Watson, or Microsoft Lewis, for example, there was the platforms leading the world in that moment. For us, it was like incredible because in that moment, for computer vision, neural networks were everywhere. The performances were very high. For language, it was very, very hard to use neural networks. RNN, LSTM, there were not performances like higher than a TF-IDF approach. It was crazy. And then, for sure, transformers arrived, and only in 2019, we changed the baseline internally, and we started to use fine-tuned BERT. And okay, cool, first time where we could use a neural approach, but each time we had to train a different BERT network and for every different chatbot, and make another training for every update in the data set, in the project, and everything. So for us, it was like 30 minutes of training for a BERT model, and for a user perspective, was too much. We needed seconds, not minutes or hours. And so we started with the research, and finally, we also did distilled version in Italian of BERT, and it was a lightweight version of BERT for Italian, and it was Bertino, and it was, my surname is Bertino. It was the first single moment in my life where I could give a name to a model. It was like perfect. And I saw before the talk, the Bertino is still downloaded and still used for fine-tuning. That's like crazy. I didn't know it. But with that approach and baseline, we served almost all the projects, all the models, all the clients that we had at that moment. Then we had to generalize the approach, so to find something that didn't need to train a new model, a new neural model each time. And so we discovered the magic word of sentence embeddings. And from the release of Sentence BERT in 2019, I think, we started to research a lot about sentence embedding. We made a distilled version of a sentence embedder for classification, and we reached the state-of-the-art approach baseline for text classification, training only the subtle vector machine model. So we had something trainable in a few seconds, very light to make in production, with all the transformers power in the sentence embedding step. So it was super cool. We were very happy about what we reached. In that moment, we have to deprecate everything because we shifted to LLMs. And in 2022, so we started to use InstructGPT. That was the first model where LLM was like fine to use in a production environment. And the great idea behind it, even for classification, was that for us, it was perfect for a few observation, many classes approach. We could use the user conversation and the context of the chatbot for classification. And so it was like a shift from the demonstration approach, like a lot of utterances, sentences of the dataset, to a description approach, to describe the intent, what we were doing, the classes and the labels of the classification. It was super cool, and this was like the progression in a test set that we had internally with a lot of projects internally, and started from 65%, 70%, we reached almost, I think, 96% of accuracy in the classification tested. And for us, this was like each 10% more was 10 people more understood in a live environment. So it was the impact was very, very high. And so the classification part was okay. What we reached with this last gap, sentence embedding was cool, but with LLM, we could leverage a much larger space. So it changed completely. Like in that moment was billions of parameters, the coder model. On the other side, the sentence embedding was like hundreds of millions parameters. And so it was like a shift in the power of the networks that we were using. And on the other side, we could use like prompting, context, and everything of metadata, let's say, to increase the ability of that step. And this is the first point for us that is important to to analyze also the next steps. Let's step back a little bit. In 2019, we also understood that we could focus on the last part, the answer part. It was not only the templating, we could use also a extraction or generation for the answer part. And so we started to make research, and the first approach, quite promising, was BERT for the token classification part. So every token passing in a dense layer will reach a label that was the start and end of the answer in a text. So text, document, a question, and the result was the label of the start and the end of the answer in the document. It was not really generation, it was only extraction of an answer, but it was the first time where we could extract dynamically answers from text and not use templating and static answers. The real changing was with T5 in 2020, and that moment was very interesting because there was Google and OpenAI making a battle between encoder-decoder approach and decoder-only approach, OpenAI. And in this moment, T5 in every benchmark was better in results in comparing encoder plus encoder-decoder approach. But then maybe not all the shades and the results were well considered in the benchmarks, and the OpenAI exactly in that moment won the battle. But T5 was the first approach to generate something, and for us was the first moment where we could use question and context as input and generate an answer for that part. And for sure, with the coder-only approach, after was easier and better in results. And so we started also for the answering part to use, for sure, prompt engineering, and so decoders only for the generation and answering part. And so in that moment, it was 3 years ago, we had a state-of-the-art classification at the beginning, state-of-the-art generation for the answering part, and in the middle, we could do anything. So retrieving answer, retrieving knowledge, making workflows to reach the good moment to answer and generate something in the answer. And it was, for us, a changing point. It was super cool, but it was not so different from before from a product point of view perspective, because intent classification became agent classification. And for us, in that moment, an agent was something little bit more complex, broader than intent, but quite the same thing. It could be a topic containing multiple intents, or maybe a task, but it was not so different in an architecture perspective. And on the other side, the answering part was only easier to make generation and not static answers. And so with that approach, we said, okay, perfect, let's start to make projects in production with that. And so already in the end of 2022, we had a super cool project that we were working on, and we said, okay, let's focus on this agent approach. For us, on that moment, it was conversational agent. It was a simplified version of an agent. But it was 3 years ago, and I think it was the good moment to start to work with them. And for us, the classification part, we started to call it mother agent. We still call it internally as mother agent. And then we had some agent workflows. And an agent for us was something that it was maximum 1,000 or 2,000 tokens for the prompt, and between 2,000 and 8,000 tokens for the knowledge. And so it was something very easy to control, because the prompt, it was all the context, or everything that we want to set in the answers, and the knowledge was something very specific and very precise to deep dive and extract the answer. So for us, it was question answering. So the agent has a context and extract the answer. And in that moment, it was GPT 3.5, just released. It was 4,000 tokens of context windows, but it was enough to make something directly in production. And it was the first use case that we developed with an agent framework. Uno Bravo is a online therapy platform. It's a very cool scale-up, where it was very important to have control. So to answer 100% of times the right answer to the question, because it's like not so easy industry where someone could ask for help, also for a sanitary point of view. And so it's very, very, very important to have control on the answers. And not also on the knowledge, but also on the tone of voice and the way of use words in answer. They cannot say illness, for example, they can have to say condition. So very precise wording also in the final answers. And for us, it was quite straightforward because the Q&A, the question answering works well with Q&A approach. They had a very cool help center, and so we took the help center as knowledge base. Every topic for us was a topic agent. And so on the right, there is a little screenshot of our platform where all the agents were like in a very specific topic that could be like a feature of the platform or something important for the user. And then behind, there were a very specific knowledge, and they have control on that. And this was the pipeline. Now I have only the information about the right now, so with the GPT-4 Mini, but it was the same thing with the 3.5. We didn't change the pipeline. It was 3 steps, like classifying, answering, and then control and check the answer to be sure like that to use the right words 100% of times. And it was very effective. The 3 steps was the first step, it was 2,000 tokens, the second 4,000, and the third 1,300. And so also the speed of each generation, the cost, it was everything very sustainable and scalable, also with the high volumes. And this very simple like pipeline for us was like quite straightforward to make in production, because with that it was low cost, fast approach, and maximum control about the answers. And some results, finally, we had very low cost for conversation, like 3 seconds at the time for the answers that were very acceptable in a chat. 3 seconds is like quite like nothing. And it was 96% of agent take-up rate, so the right agent took up. There is always some percent of out-of-context questions and everything. And we reduced the 70% of tickets for the customer care part. So even for a very like fast deploy in production, the results were like super meaningful. But that was the easy case for sure, because they had an help center, very like structured knowledge, and in reality, knowledge is not always easy to handle. And coming back to the question answering pipeline, for sure, other applications in the world were handling more complex knowledge. And everyone started to like split the knowledge, for sure, in portions, but then they started to retrieve the knowledge using sentence-embedded similarity. So everyone stopped to talk about question answering and started talking about RAG. And what was the problem? That the pipeline, so as we saw before, we have agent classification, knowledge retrieval, and answer generation. For the first and the last step, we keep the state-of-the-art approach, but we are starting again to use the outdated sentence embedding in the middle for the retrieving. But finally, this is the most important part, because if we don't retrieve the right knowledge, we could not answer in production. And also, it's less, it's much harder to have control about the hallucination. And the retrieval augmented generation became a roughly answer guessing, because you maybe question answering, because if you don't have the knowledge, you are asking the LLM to infer the knowledge that it doesn't have. And so it's like asking the LLM to hallucinate. And so the challenge changed completely. Before, 2 years before was increasing the response rate. It became decreasing the error rate. And this was like the most impactful point in all the productions, RAG, all the production chatbots that I saw in different approaches. And there were like companies starting to make 1,000 documents in one agent making RAG. And yes, it depends on the error rate that you can keep in a production environment. But maybe it's like a simplification. And for our point of view, it was like a coming back to a problem that we solved 2 years before. And so memes started to like spread everywhere in the web. Like RAG is dead, long live RAG. It was like the meme about RAG that I saw more often in the web, because everyone that didn't know how to it worked before RAG, they started to make RAG, and they say, okay, but it cannot hallucinate like that. Let's use a full context approach. So don't split the documents. Let's fill all the knowledge inside the prompt, so we don't have the problem to retrieve the knowledge. The problem is that LLMs have a decreasing performance in context window. So if you use a 100 tokens context window, you don't have the same performance, you have higher cost, and also you have to use the more intelligent models, and so the cost increases directly. And so there was this alignment on what we were doing and what we were seeing elsewhere in the industry. And that was the moment where we realized that RAG was like giving all the power to LLMs, but not considering that data need some working on it. This is a data scientist, happy data scientist's photo for AI. Only to say that from my perspective, I came from a mathematical profile. I did mathematical engineering in Milan, and generative AI was like the enemies for mathematicians, because for sure you are like relaxing all the hypotheses. You have to removing the modeling part, and you say like, let's use English or natural language instead of numbers and data and models. But turning like the point of view, maybe that moment was, okay, let's step back and make some more work on the data to automatize that part and not the inference part. And so like language models starting to move the power, the computational power from the training part to the inference part with the reasoning models, the same for using in a production environment is taking what was in the inference part with the RAG and moving it from the uploading and handling of the document part. And I have two more use cases with very different data, but only to understand how we handled in different cases these approaches. The first one is the e-commerce use case. I didn't take a precise client, but for example, here is the database of Yves Rocher, I think. But for us, e-commerce is quite the same because you have a catalog of products, and catalog can be huge. For example, now we are doing a chatbot for Quattro Ruote in the car industry. They have hundreds of thousands of cars in the database to choose the right car for the user. So database can be huge, but for sure you don't need to fill the whole database in the prompt. And so the idea is to leverage LLM in all the steps that you can, but avoiding the hallucinations and too much tokens. And this was, for us, the pipeline to follow. On the right, you see a screenshot of a trace of a real answer in production on our platform. And what we do is, for sure, classify the agent like before, and then start to classify some metadata, some aspects that the language model need to understand to filter this data, to identify the right piece of data. And so it's a different point of view. With the RAG, you give to the responsibility to the LLM, to the sentence embedder, to make all the research similarity-based. In this case, we shifted completely. We use LLM, but for identifying which are the aspects to retrieve the right portion of knowledge. And so the idea, the point 2 and 3, is, okay, let's identify the category or a collection. If you don't have it, you can ask it to the user. And then identify all the optional filters that you can need to filter your database. If you don't have it, you can ask the user to give more information, more context. All this information is structured information that we can use to query a database to make an API, and then have the right amount of token to make the recommendation. Everything here is generative because the identification of the agent, the extraction of the category, of the filters, every step is generative. But the orchestration of the steps is programmatic, is a workflow. It was like our starting point to leverage the LLM, but to have control in a programmatic way. And finally, also in this case, the cost, the speed and everything was very effective. Yes, for sure, you need more steps to reach the answer, but finally, you have a classification. In this case, we used, for the classification of the category, we are using Gemini Flash, and we use Foromini for the less reasoning part, like the simpler tasks. And for the recommendation is the final recommendation is the only step with a lot of tokens, but a lot of tokens for us is like 20, 30,000 tokens, but it's only for the final step when you have all the information about all your catalog. This is interesting, for example, to choose the right model with the right cost for every step. We released open source 2 months ago, Chatbot Arena Italia, in Italy, the Italian version, because we used a lot Chatbot Arena in the English version, but we focused on the Italian language, so we needed a focus on that. And so we started to using it like internally to use the models, and then we released open source only to make a contribution for the community. But we still testing a lot of language models for Italian language, because in every step we have to understand what is the most effective language model to use, as in this case. I wanted to show you some code, some Python code, but unfortunately these pipelines, we do it with our low-code platform. So even my job a few years ago was like coding in Python the whole day. Today is using products and coding when the products are not enough. But the concept behind is exactly the same. The pipelines, this type of pipeline, you can do it with LangChain, with NumIndex, with small agents, whatever library that you want to use, but finally is the concept behind that is important to optimize. The last use case is the more complex, and it was like another client where we had PDF documents, and these documents were like noisy and incredibly difficult to handle. It was more than 1,000 documents, more than 4,000 pages of documents in total, 5 different streams that for the client was a financial client for different branches of the company, with a product that had 3 levels, a financial product quite complex. And these are the nightmare of chatbots, so to handle unstructured information like that. But finally, doing RAG with this, it's impossible, because you have documents, we had documents with the same structure for different financial products, for example. This is impossible to slightly change the similarity when you have where the most important information is the product that maybe it's not even expressed in that chunk or in the whole document. And so what is important is the metadata, is every information that you know when you are modeling this knowledge about the documents. And so for us was like changing the approach. If RAG is a bottom-up approach, you identify the chunk, identify the document, we change the approach top-down. So identifying the document and the portion of knowledge, and then retrieve that portion of knowledge. And so using exactly the same approach of the catalog products. So if you see a knowledge like the filters are the information that you can extract when you upload the documents, the text and the content is like your product. And so the pipeline is the same, but identifying the right portion of knowledge instead the right product. And so for us, we started doing approaches like that without even focusing a lot on about a generic stuff, because we were seeing that there was not a single approach to fit all the possible problems. And so we started on a production point of view. So we started to say, okay, let's analyze every case, but finally we do the same approach in every aspect with the same concepts. We were speaking about programmatic workflows, this orchestration that we do with these programmatic workflows. But if the orchestration is delegated to a single point, a single LLM, this is the next-gen AI agents. We are starting already doing it with simpler tasks, because with complex tasks, we don't have the performance yet to delegate everything to one agent. But finally, the concept that we see everywhere about agents is to orchestrate dynamically what we can do programmatically, manually in a workflow. And so this is the buzzword for sure in this moment, but there is a reason behind the buzzword. We don't have to make the same mistake as RAG, because agents are not the solution for everything. Now, if you ask a too complex work job to an agent, is like to ask to a RAG to do like search in 1,000 documents where it cannot be done. But for sure, it's more adapted for reasoning and for exploiting the real power of LLM, and to forget a little bit the sentence embedded, that it was like the problem that we solved already a few years ago. So when we ask ourselves how to go into production with generative AI, our simple rule is that we use LLM wherever they can solve a problem without causing a new one. So wherever you can be sure to control that point and the step, and you are not creating new problems or new hallucinations, so you can be sure to use it and deploy it. Thank you.
Okay, thank you so much. We do have time for questions. Who wants to start? Here we go.
So thank you. The talk was very nice, the historical perspective, and liquid gold, all the case study you shared. And thanks for spelling that RAG is problematic. Do you think this will be forever? So every time you hear RAG, so graph RAG, hide, whatever, you stop your brain, or there is anything you are following or something that you want to see solved before trying again to investigate into RAG?
Yeah, for sure. The problem is that RAG last years was seen as a fits-all solution, so something that can fix every problem. But it can still fix problems. We use RAG in our platform inside an agent when we don't have too much knowledge and when knowledge is beyond well distributed. But it's only not yet a solution for every type of problem. There are cases where graph RAG is very effective and is very cool to use it. Cases where contextual RAG is very effective, so we use it in some cases where we augment the context when we embed the chunks. But yeah, I didn't focus on these cases only to be quite sharp on the concept and to be a little bit more controversial on that. But for sure, RAG is effective in some cases, and we still use it. There is also a limit of the technology today. Embedding models have a limit today, but maybe not tomorrow. Already we are, for example, right now testing a lot the new embedding model of Cohere Embed 4 that is very cool, long context window and good performances. So it can change in the future, and we are researching a lot about it. But it's like always asking ourselves which is the best approach for that problem. And then, yeah, for sure in a few years, even data scientists will be replaced. So we are all sure about that.
Anyone else? Oh.
So since you're talking about conversational agents in production, and since you started even before there was conversational agents and simple chatbots, as we said in the historical timeline, I was wondering what are your, what have you done and what are your suggestions and hints relating to the LLM evaluation, so like LLM at JADS or whatever, in the sense that I think that you probably also already had this kind of problem even before agents and whatever, and the new era. And for sure, you said in one slide that you the business problem switched from avoid incomprehension and to avoid error rates in answering. So I was wondering, since at the moment I see that LLM evaluation is always something very use case, it's a project in a project in some way. So since now you have to deploy multiple projects, multiple chatbots with different contexts and whatever, have you found some way to generalize in some way how to evaluate like methodologies or whatever to understand and address this?
Yes, this part is it's easier to standardize and to have a common approach for every project. For example, we have evals on every chat, on every chatbot, and the methodology is the same across projects. For every project, we can have different evals, but it's only different prompt for us or different shade of what you are evaluating. But it's more about evaluating the conversation. So finally, you can evaluate, yes, the errors, and on the other side, all the, for example, possible insights or possible information that you can gather from the conversation. But this part, yes, it's more easy to standardize because finally you have a same input that is the final conversation, and the same steps, that is, take the conversation, analyze these aspects, and then extract the metrics to visualize or to have alerts and so on. For sure, the performance limit is the LLM that you are using as a judge in that case. And that if for generating the answer you're using the state-of-the-art LLM, it's not always possible to evaluate correctly this state-of-the-art because the judge is the same model. But in general, for our cases, it's more common that we use simpler and smaller models in the pipelines, for the costs, the speed, and everything. And so we always have a bigger model to judge and to evaluate the conversations.
Do you have a ground truth on evaluation?
No. Yeah, no, we don't have a ground truth. This is a big challenge to have a ground truth. No, we do directly as a judge, trusting the LLM in that case, yes. Yeah, it's a proxy. It's a estimation of the evaluation, yes.
Okay, any last question? Okay, then I have a question for you. So I come from vision and computer vision, and you can usually do like RAG in two ways. The first way is, I split my document, maybe I do some OCR stuff, splitting, then I embed my text, etc. But there are some new models, maybe in the last year or something, that will search with vision instead. So basically, you take a PDF, you convert each page to a PNG, and then you embed that as an image, and you have some special model that can actually look in which part of that page, you get probably some information. And then you usually do the re-ranking process, as you will normally do. I was wondering if you also experimented with that, or if you have some insights by using different modalities than text?
When I talk about knowledge, it's not only text knowledge. It can be text and image, so multimodal approach. I think that it's the same point of view. Like if you do RAG in a multimodal approach or a text approach, it's quite the same thing, finally. Multimodal, you have, it's more challenging. So maybe you have much more errors. But finally, it's quite the same thing, because if you retrieve knowledge and you use knowledge for answering, it can be vision embedding and retrieving also images, and vision, text vision answering and multimodal answering. Also, the new embedding models are like multimodal embeddings. So it's like the generalization from text to text images, so text images, sound, audio also. It's quite natural, I think. But everything that I said for text, I think that is the same for a multimodal approach.
Okay, so thank you so much again.
Thank you.